Thank you for joining us today. Hello, friend. So, what we're looking at today is the world of PC building. So there's plenty of PCs that you can go out to Best Buy and check out, and it'll have all sorts of doodads and whistles and all, but that's built by somebody else. And what we're trying to figure out today is how hard would it be to do it yourself, to find your components and do it without, somebody else doing it for you. One of the benefits is it'll save you a lot of money. You go into a boutique computer shop and try to build something either for engineering or gaming purposes, it can run you something above, $1,300, $1,500. Whereas if you put it to your own skills and find these components individually, they go on sale all the time online. If you look at places like Amazon Prime or Newegg.com, they'll have them at half the price, 75% of the price, you name it. So we're going to be looking at that today live. So this case right here is what we're going to be kicking things off with. It's made by Corsair, the brand, and it's their 200R model. I think the case itself is about maybe $50 if you look for it online, but it's got a lot of high-end features that you wouldn't find on, older cases. It's got USB 3.0 on there, meaning that all of your transfer speeds for your up-to-date thumb drives will be faster, as well as plenty of space on the inside, especially for an entry-level PC builder, to be able to wire things up, get a motherboard inside, have room for tools and other things, just so you can get your grounds and your bearing. And this is the first case I used when I first got into the PC building game, which wasn't that long ago. It might have been about a year ago. Before that point, I didn't know much about computers either. I wanted to buy something put together for myself, and then I was inspired by a YouTube video that I watched that had, who's familiar with the game Skyrim? Everybody know Skyrim? I saw Skyrim modded with the ENB mod to give it like super realistic graphics. And I thought, okay, I can't achieve that on just my Xbox 360. I need to get in this PC game. Which, of course, what I should be building a PC is for AutoCAD and SolidWorks and MATLAB. But the first thing that spilled me over was entertaining. But it also has come in handy with other software for 3D rendering and all sorts of other things. This one is my current build, so after coming from this beginner case and figuring out the basics of how it goes together, you can then move to larger things and more sporadic things. So this current one isn't shaped like a regular computer that you might be used to, like a regular desktop. This is more of a cube form factor. They have it along the lines of like a test bench. And what they mean by test bench is that if you were in the field of instead being a reviewer on YouTube to go through different components and you're swapping things out constantly, this makes it easy to have everything accessible as well as have a lot of airflow over your components. And that's something we're going to go over a little in later on in the presentation, just how much heat can be created when you're running something powerful. So from the get-go, let's start at some of the basics. So there's going to be, you're used to seeing, I might have to turn off the lighter here. Let me try that for a second. And then I might need y'all's input as to whether we can still see our papers. We turn off the lights. Everybody can still see to write down some notes and all? Yeah. Okay, cool. So here we have a regular old Dell computer that you either see at your parents' house or on school campuses. And they're built by the manufacturer with just productivity in mind. It needs to be able to calculate things. It needs to be able to turn on, maybe run Microsoft Word, not in 4K, but just Microsoft Word, and get the job done. It's done for productivity. But if we put together our own, we can exceed the specifications or exceed the capability of these machines just by adding a little know-how onto it. And today's presentation is all about letting you know the best possible. And I don't want it to seem too intimidating because it was for me for a while. So where things begin in a computer is the motherboard. The motherboard is going to be the backbone that holds all of your components. There's about maybe 7 different main components that you need to put together a PC, and those are all held together by the motherboard. So the one that we have here comes out of our PC that we use in our IEEE office just across the hallway. And we've taken it off here to show it at its barest. So on your sheets, you'll see that there's a similar diagram. It's not one-to-one with what we have up here, but a lot of the main areas will be the same if you were to go online and shop for a motherboard for your own. They range in price from about $50 at bare bones to up to like $300 if you want it like bulletproof with Kevlar and lights and stuff, but none of that's really necessary. So maybe of a good ballpark, $80, $90, but we'll see that in person in a little bit. So if you look in the top, the top center, you should have a familiar little square up there, or a little rectangular area. That's where your CPU goes, the CPU. And the CPU is where the computer is going to be doing all of its thinking, of course. Anytime you put in a calculation, anytime you tell it to do a process, that'll go through your CPU. And what that really is it's billions upon billions of transistors, which in EE we're going to be learning that those are essentially switches at the tiny level. The switches that do logic to run the process, which then talk to the registers and everything. We're not going to go too deep into that. And all of that process creates a lot of heat. It creates a lot of heat. So on the very top of it, it'll have this metal portion, which is the heat spreader. And if you were to run a PC by itself, the way that we have it here, if you can see on here, this is where our CPU is, it would burn up. It would fry. It would fry the CPU if you didn't place a piece of metal onto it to disperse that heat. It doesn't disperse it naturally well enough to run on its own. Exactly. We got a section over here if you'd like. There we go. So to remedy that, we place a heat sink. We place a heat sink on top of the CPU so not to allow it to burn up. And let me show you an example here. This is just a regular stock heat sink that you would find if you were to purchase a CPU on the internet. This comes with the CPU. So essentially what it is it's a block of aluminum that would make contact with your CPU. And then it's also attached to a small electric fan that'll plug into your motherboard. And altogether what that does is its main purpose is to take all that excess heat that's coming off your CPU and get it elsewhere, get it away from the CPU. So it mostly just blows it into the computer case, and then other fans on the case will dispel that out as exhaust. So that's why we protect our CPU with a heatsink. Granted, so the one that we have here, it's kind of a square shape, and the one displayed here might be a little more popular. It's a circular shape, but they do about the same thing. So these belong to two different brands. If you were to talk about the two different brands in CPUs, can somebody give me one of the examples of the two main brands in CPUs?
Intel and AMD.
Yes, those are the two heavy hitters. So the square one here is sold by AMD. And AMD's been in the game for quite a while, but currently Intel is found in more machines. But the Intel sometimes run a little pricier, which is fine. They tend to two parts of the market, one that needs something to get done and can find a little more budget, and then when you've got a higher task to forego, you can throw an Intel CPU on it. So the way you can liken those two brands, I guess, in the automotive world, as far as American automotive goes, we've got like Chevy and Ford. So they both provide a service. They both do it plenty well, but there's also a lot of people that will swear by one brand and not the other. So we fall into kind of like a brand loyalty. And if you were to go online and kind of research a lot of these things, you're going to see a lot of that in forums of people saying, here's why I don't like brand A, and then a lot of people saying, well, this is why I don't like brand B. It's all fine and dandy. A lot of that comes from just the customer experience of what they've bought in the past, and maybe it went one way or another. But both brands do you just fine, specifically on what your own needs are. So with that, this one This is also a heatsink. You can recognize that this is the motherboard down here, but this heatsink extends like half a foot off of the motherboard. And what's going on here is that it's an aftermarket heatsink. It's not one that you'll find packaged with a CPU. This is one that you buy separately from a CPU if you're looking to what they call overclock your central processor unit. Overclocking is a method of injecting more voltage forcefully through your CPU to try to get more performance out of it. More performance than the manufacturer originally intended for you to. But in doing so, that's going to create more heat. So with that extra heat, you'll need a better heat management solution, and that's where these larger heat sinks come from. The one that I've got displayed here is a very popular one. It goes for $30, which is great for the value, and it's made by Cooler Master. Cooler Master is the brand, and this has been a standby for computer enthusiasts for the past maybe decade. So the Hyper 212 Evo, if you were to go on the market, and I mean it's easy enough to find if you go on any of these shopping websites that we're going to explore today, you can simply go to the ratings area, and it'll be one of them at the top. So now we're going to look at some of these connectors that we